to introduce Johan, who is a professor of the Sustainability Transition Policy at the Friedrich-Alexander University. And it's somehow a special webinar for me this time because Johan used to be my professor at University of Potsdam on energy policy. So, yeah, the floor is all yours, Johan.
Thanks, Ricarda. It's also good to hear me. Apparently, I did something right because we keep on meeting here and you keep on wanting to talk to me. So apparently, we did something right at the university. So thanks. I'm going to say a couple of words to introduce this topic about the work that I do, the specialty of me, looking into decarbonization policies for how to create a zero emissions energy future. And it's going to be a little bit sweeping to go across the board. And I'm going to arrive at, I think, three big messages that I really want to get across here. So I hope it's going to work out fine. So, I mean, first of all, we talk about the zero emission energy. We talk about full decarbonization for a reason. All takes place in the context of the Paris Agreement and the temperature targets of the Paris Agreement, setting limits to 2 or 1.5 degrees warming above the levels of pre-industrial times. And these targets seem a little bit inconspicuous, right? But actually they are not, because when you put carbon into the atmosphere, the temperature reacts more or less linearly. The more carbon you put into the atmosphere, the higher is the temperature increase you get, which means that for any temperature target, there is a carbon budget associated with it. That carbon budget is, of course, a little bit uncertain, but there is a carbon budget and there's a number for that. Well, for an amount of carbon we can put into the atmosphere before we surpass some threshold. And that's going to be a little bit higher for the 2 degrees target and a little bit lower for the 1.5 degrees target, of course. But the key point here, and the thing that is really policy relevant with these carbon budgets, is that it is a number, it is a finite number, meaning that sooner or later, sooner for the 1.5 degrees, a little bit later for 2 degrees, and yet a little bit later if we were to go for a 3 degrees target or 4 degrees target, we need to reduce our emissions to zero. Our net additions of carbon into the atmosphere need to sink to zero, because that's the only way that we can stop global warming at any level, regardless of which temperature target we have. So that's the first point to make. Then, following from physics, these temperature targets mean that we need to go to zero emissions. We do not need to reduce our emissions. We need to eliminate our emissions. Second point then is, well, if we start thinking about our emissions, we can think, what are the things that cause our emissions? What are the things that drive our emissions? And we can do this with an old concept. It's, I don't know, it's 50 years old or something like that. We use this so-called Chi identity to figure out the CO2 emissions of countries in the days before we had proper CO2 emissions accounting. So we didn't have data for national CO2 emissions, but we did have data for population and for income per person and for energy intensity and for CO2 intensity. And if we do all of these things together, we multiply all of them, we get the CO2 emissions of a country, right? Because the more people we have, ceteris paribus, we're going to have higher emissions. The more economic activity these people do, they're going to cause higher emissions. The more energy that economic activity uses, increases our emissions, and the CO2 intensity of the energy that we need to use in order to drive our economic activity also increases the CO2 emissions. So you can do the math and you will see that what I have posted here on the screen says CO2 emissions equals CO2 emissions, if you really want to do it that way. This is relevant today, not because of accounting reasons, but because it helps us to focus our efforts. It helps us to find out where do we need to look. So if we learned that the CO2 emissions must be zero, well, the population cannot be zero, or should not be zero, preferably. Our economic activity cannot be zero, because if there are people, they're going to do something, and that is going to have an effect on the environment. If we have economic activity, they're going to need to use some energy for doing that. And that means that all of these factors before cannot be zero, and it means that the CO2 intensity of the supply of energy must be zero, and it is also the one of these parameters that can be zero, right? So what we can learn from this Chi identity is that all of these efforts looking into efficiency and getting rid of capitalism and such things, they may or may not be useful, but the one thing that we must do is to reduce the CO2 intensity of the energy that we use to zero. And if we do that, it doesn't matter at all what the other factors are, because the population can be however large. If the energy that we use does not cause any CO2 emissions, then we do not cause any CO2 emissions. So a second point to bring across in this talk is that these things, efficiency and decarbonizing supply and so on, they are differently important. So that reducing demand, going with increasing efficiency or with sufficiency measures are useful for the Paris targets only to the extent that they make decarbonization easier, faster, or cheaper. And I think the jury is still out on each of these measures, whether that is actually the case. We must work with the supply side. So, third point then, if we must work with the supply side and the key to decarbonization lies on decarbonizing the supply, then we enter the world and think, okay, we must build a new zero carbon energy system. How do we do that? And from the policy side, we would think about, well, we can classify policies in many different ways. I like to classify them as positive and negative policies. On the one hand, we can spend money and spend efforts in order to create a new system, something that is new and desired, and a zero carbon alternative to replace whatever activity it is that we have today that causes emissions. Or we can work to penalize the undesired carbon intensive technology. So very often the debates are, should we work with subsidies and standards and these things, or should we work with carbon pricing on the other side? And this is a debate we can certainly have all evening if we want to, but I'm just going to show some examples on why they are differently important, why they are differently effective. So if we work with the penalized stuff, the things that we do not want, we start in a situation where this lady has her car and she's happy about driving her car. Only problem is that it causes a lot of emissions and it's not particularly sustainable to do so. Then we ask around, we ask economists maybe, what should we do about this? They say, well, she drives too much, so we need to put a price on the carbon that she emits, and then she will drive less. The problem is if we do this, many countries already do that, if we only do that, then what's going to happen is that, well, we think she's going to take the bus, but if we don't have a bus, the only thing that's going to happen is that she's going to be upset with us. She's not in her beautiful car anymore, but she's standing on a cold and drafty street waiting for a bus that doesn't come, which is not a good policy approach. So instead, what we could do is to force change or support change by making a zero carbon alternative attractive. So the same woman in the same car, she's still happy because she thinks she can drive a car. In the meantime, we've been building a subway system or a bus system or a train system or whatever works in the particular context that we are. And then we will see that she shifts to this subway system simply because it is better. Maybe she doesn't shift enough, and we also have to work with the negative policies to really make sure that this shift happens. But only when the positive alternative is there is she able to shift. We cannot force people to shift into something that doesn't exist. We must first create the system, and the new system, we must first create the alternative, and then we can talk about how do we make people shift with these penal policies, with these punishing policies such as taxation or removing parking spaces or whatever it is that we want to do. First of all, we need to work with positive policies to create the new, and then we can work to get rid of the old. And if we look at the history of climate policy in the EU, so not all of these are going to be on some exam, I suppose, but this is a more or less comprehensive overview of EU climate policy over the last 30 years. We see that we have a set of positive policies. In particular, we have the renewable energy directives that put mandates or support the deployment of renewables. We have an energy efficiency directive, eco design, and so on, that sets standards for the good things that we want to have in the market. And we have a relatively equal balance with the negative policies, in particular, carbon pricing, emissions trading, the effort sharing stuff, and so on and so forth. So we see that the European Union, and we would see the same for most countries, they have roughly a balance between these positive and the negative policies. But if we look at the effects, which of these policies are actually effective, which actually drive change and reduce emissions, we have this very simple figure. I'm going to walk you through this because you're not going to be able to understand it on your own. This is from a paper that was published by some colleagues of mine just 2 weeks ago. So it's brand new and it's totally awesome. So what this paper shows is a couple of things. First of all, what they show is that all the policies in the world, the climate policies in the world, have reduced emissions by these 6.4 gigatons, which is about 15% of global emissions. So climate policies have an effect. That's a good news, and we can actually measure this effect. If we look at which policies had the biggest effect, about 50% of the observed and attributable reductions come from renewable electricity support policies, such as the stuff that we've done in Germany, and much of this stuff has happened in the European Union. About 10% of the emission reductions can be attributed to efficiency standards, in particular in buildings. 3% can be attributed to carbon pricing, and the rest can be attributed to various things such as heating subsidies and so on and so forth. So the point is, we spend about 50% of our policy effort on negative and 50% of our effort on positive policies, but almost all of the effects that we can see are attributable to the positive policies. They are the ones really driving change. They are the ones really reducing emissions and changing systems. So maybe we should put a little bit more emphasis on these things, not fight so much about which is best, carbon pricing or not carbon pricing, but just figure out how do we create these new alternatives in the sectors that we want them. The last point I want to make is very short, because it's leading over to what I think Katarina will say, is that when we create these new alternatives, we need to consider that technologies are different. Of course, cars are not horses, oil heaters are not heat pumps, and so on and so forth. That means that the infrastructure that is needed is different. So the infrastructure needed to fuel a gasoline car is not the same that we would need to fuel an electric car, and it's certainly not the same that you would need to fuel a horse. It's just fundamentally different stuff that we need to do. But if the aim of these policies is to create attractive alternatives, we must not only think about the artifact, about the car, about the windmill, and so on and so forth, but especially we need to think about the system, namely the infrastructure. So my key points are, we need to think about how do we decarbonize supply. This is the first priority, and not all of the rest with efficiency and whatnot. We need to work with positive incentives because they're more effective than negative ones, and we need to think about how do we make attractive systems, and that solution lies within the infrastructure, not only in the deployment of new technologies.